Team Ondo, and we'd like to introduce you to our product, Ondo. But before we get started, I'd like to introduce you to our team. Our tech lead was Takashi, and he also worked as a full-stack engineer. Myself, Joe, I'm the product owner, and I was a full-stack engineer and also worked on the hardware. We have John, our back-end lead, who is also a full-stack engineer. Marie, our front-end lead, who worked on the user interface and web design. And Sergey, our back-end engineer, who also worked really hard on the hardware as well. The five of us started this project, and we were trying to think of what problems we wanted to solve. We came up with trying to solve the problem of heat stroke deaths in Japan. So in Japan, heat stroke related deaths and illness have skyrocketed, particularly among the elderly. In 2020, over 1,500 deaths were recorded in Japan due to heat stroke, and this was a 200% increase in heat stroke deaths since 2017. There were also 14,000 people that were hospitalized from heat stroke during the week of June 27th alone. And if current climate trends continue, the problem is only going to get worse. So we were hoping to find a solution.
So who is Ondo for? We imagine that the main user base for our product would be twofold. So the first type of user would be someone like Yoshi, pictured here. Yoshi lives in the city, but he has elderly relatives who live in the countryside, so far away. And he's concerned about the summer heat getting worse every year. He reads about it, and he wants peace of mind that his parents are keeping safe during the summer. The second type of user that we imagined for the product would be someone like Atsuko. She's a care worker who lives in the city, and she looks after quite a few elderly patients who all live in apartments inside the city as well. But it's very difficult for her to check in on everyone, particularly during the summer. She becomes anxious that she doesn't have enough time to check in that everyone is keeping safe. So she wants something that will notify her if she needs to step in and take action.
For our hardware prototype, we have our sensors hooked up to the Raspberry Pi. Ondo is always monitoring the live temperature and humidity of the room. It also monitors motion in the room to tell if someone is home or not. If we look at the program monitor, we can see the current status, which is that someone is in the house and the temperature is okay. The temperature threshold is set by default, but can also be updated remotely by the caretaker using the Ondo app. The temperature is normal, as you can see by the green LED light. Here we are breathing on the sensor to simulate heat. If the temperature gets too hot, the red LED will blink, and an alarm will go off, notifying the user and prompting them to turn on their air conditioner.
お部屋が暑くなりました。エアコンをつけましょう。
To snooze the alarm, we push the snooze button. The red and green LEDs blink to show the snooze status, and the alarm turns off for a set period of time. If it's still too hot after the snooze period, the alarm goes off again. When the alarm is activated, a notification is also sent from the device to the Ondo server, which then sends an SMS notification to the caretaker's mobile phone. The alarm can also be deactivated remotely by accessing the Ondo homepage. Once the temperature returns to normal, the alarm stops and the status returns to in-house temperature OK.
お部屋が寒くなりました。暖房をつけましょう。
The same process occurs when the temperature is too cold in the house, only this time the alarm prompts the user to turn on the heater instead. Whenever a user leaves home, they can set the device to out-of-house status. During out-of-house status, the green LED will blink. If temperature conditions are too hot or cold, the red LED blinks, but the alarm is deactivated since no one is home. Once the user returns back home, the motion detector senses they are back and sets the status back to in-house. This will reactivate the alarm if the temperature becomes too hot or cold and motion is detected.
お部屋が暑くなりました。エアコンをつけましょう。
I'd like to now quickly go through the user interface side, which will be the main portal for the caregiver to interact with the product. So this is the welcome page for Ondo, where users can sign up for a new account or sign into an existing one. Here we have the mock-up of the device on the table in the background. So this page also functions as an introduction to the main features of the app. We introduce the device itself here. We show an example of the historical data visualizations that we have, and also of the notifications page. Okay, so let's try and sign in. We can use a test account to sign in here, clicking the button. The server may take a moment to authenticate. This will then take us through to the live data top page. We can see for the purposes of our example here, we have the alarm set as ringing. When this happens, an SMS is sent from the device, and also this pops up on the user interface. So we can check in at this point, see if everything is okay, and if necessary, we can click on this button to push to the device to turn the alarm off remotely. We also show the local weather conditions, the name of the current device that we are viewing, and the temperature and humidity conditions being streamed from the device sensors. Next, we can look into the historical data. So this visualizes all data by day, week, or month that has been sent from the device in the past. We can click into graphs in this way to see the temperature, scrolling down for the humidity as well. And then at the bottom we have the alarm history, which has timestamps to show every time the alarm has been triggered in the past. Moving on to the settings page, we are able to select the current device we want to view, and we can view the user settings and device settings. You can change these by clicking through into this form, change the temperature thresholds, for example. Finally, we have the notifications page, which summarizes all notifications from the device. You can click in to read the details. You can sort by unread or read status. And you can see that the types of notifications are all color-coded for easy reference. And so that's the main user interface of the caregiver side that the caregiver will be interacting with. Logging out takes us back to the landing page, and that concludes the demonstration.
The architecture for Ondo is as represented in this diagram. The device houses the sensor and is connected to the Ondo server. The server has a number of endpoints to talk to both the device and the UI. We also built Postgres database to store and retrieve information from both the user and the device sensors. The browser UI displays live and historical information for caregivers about the device status and provides additional notification when necessary. Also, when the device detects that house getting hot or cold, it will send a request to the server, and the server will send an SMS notification to the user's phone. Our tech stack is as follows. First, for the hardware side, we use Python for the main language to communicate between the Raspberry Pi and the backend server. Adafruit is a sensor we use to detect temperature. Pygame was used to sound the hardware alarm. And finally, Socket.io was used to set up communication from the backend server to the hardware. For the server backend, we also use Python for the main language. As we all use different operating systems, we use Docker to standardize the development environment. We use FastAPI for building our RESTful API, JWT for our authentication. We use Twilio to send SMS notification to the user's phone. And finally, we use Postgres database to store our data. For the front-end user interface, we use TypeScript as our main language. We also use the Next.js framework to organize the front-end code. We use Chart.js to visualize the data from our database in user-friendly graphs. For styling, we use Sass, and also Radix to help make a custom user interface components. Finally, backend and frontend were both deployed using Render.